Okay, so in this video, we learned already about arithmetic sequences and geometric sequences. And in this video, I want to do something with them, which is to do the sum of an arithmetic sequence. Arithmetic sequence. So that's what I'm going to do in this video. And this formula for the sum of an arithmetic sequence, it comes with a little bit of an urban legend of the famous mathematician Gauss. When he was a kid and he was like 10 years old, he was very annoying, obviously, being a nerdy math kid in the 1800s in Germany. I hope it was the 1800s. I don't know. Maybe. It was old-timey Germany. Okay. And so he was annoying his teacher, and his teacher was like, Gauss, I want you to shut up. So please go sit in the corner and add up the first 1,000 numbers. So the teacher says to Gauss, please find 1 plus 2 plus 3 plus 4 plus ... plus 999 plus 1,000. So Gauss has to add these up. And the teacher is thinking that Gauss is going to be there all day. This is before calculators, of course, so he had to add them up by hand. And the teacher's like, great, now he won't annoy me for the whole day. But 5 minutes later, Gauss comes back with the answer. And the answer is, oh boy, I better get this right. The answer that Gauss came up with, this number, 500,500 is the sum of this sequence. And the teacher's like, mind is blown. Like, how did Gauss do it so fast? And the reason is Gauss discovered an amazing trick that I think is just so beautiful of adding up the sequence without having to do the work of literally adding them all up. And that's a cool trick. So I want to show you guys how you get this thing. And it is later in the notes. So by doing it now, we are going to save some time later on where we do the sum of arithmetic sequences. So how do you do this sum? So here is what you do. First of all, let's give this a name. So this is the magic of algebra. Whenever you want to find something, give it a name. We're going to call it S. So S is 1 plus 2 plus 3 plus 4 all the way up to 1,000. We want to solve for S. Okay, but that doesn't actually help anything. Here is the real trick, which is let's take the equation we have and write it down one more time backwards. So S is 1 plus 2 plus 3 plus 4 all the way up to 1,000. But of course, it's the same forwards and backwards. So of course, S is also 1,000 plus 999 plus 998 plus 997 plus ... plus 2 plus 1. So this is the trick. If you remember this trick, let's write it backwards. All the other steps are not hard. That's the only magical trick. Write it backwards. That's going to help us somehow. How is this going to help us? The trick is to realize that now that we have written it backwards, and if you look in every column, so let's look at 1,001. 1,000 plus 1, if you added them together, would be 1,001. And what would happen if we looked at 999 plus 2? That would also be 1,001. And what would happen if we looked at, say, 4 plus 997? That would also be 1,001. So now the equations are stacked up so that every column adds up to exactly 1,001. And why is that so nice? Because one of the things you can do in algebra is you can add equations. So if we take equation 1, this equation 1, and we add it to this equation 2, of course, they're the same equation in reverse, but don't bother with that right now. They're two equations. If you add them together, what do you get? On the left-hand side, you have the formula 2s. S plus S is 2s. On the right-hand side of the equation, you are adding up these things, and I want you to add them up column by column. So 1 plus 1,000, 1,001. 2 plus 999, 1,001. 3 plus 998, 1,001. 4 plus 997, 1,001. ... Do it a bunch more times. 999 plus 2, 1,001. 1,000 plus 1, 1,001. So on the left-hand side is 2s. That's great. We're looking for s. On the right-hand side, we have 1,001 added to itself a bunch of times. How many times did we add it to itself? Well, we did it 1 for each term, 1,000 terms. So on the right-hand side of the equation, we're adding 1,001 to itself 1,000 times. So that is exactly 1,000 times 1,001, right? Adding something to itself a bunch of times is just multiplication. Look at this. We got 2s equals 1,000 times 1,001. And if you just take this 2 over here and move that to the other side of the equation, you have the answer. Therefore, s is equal to 1,000 times 1,001 divided by 2. And if I did the math correctly, this is 500 times 1,001. That is exactly 500,500, which is the answer that was promised at the beginning of the video. S is 500,500. So this is how you do the sum of the first 1,000 numbers, and this trick works for the sum of any arithmetic sequence. So let's do sort of the general formula, and I'll show you how it works. So the general formula is like this. You want to do the sum of some sequence that starts with A1, and then the next term is A1 plus D, because that's how arithmetic sequences go, all the way up to A1 plus n minus 1 times D. So this is also known as AN, right? In an arithmetic sequence, the nth term is A1 plus n minus 1 times D. If you want to know what the sum is, you flip it around. So S, on the other hand, is equal to A1 plus n minus 1 times D, plus A1 plus n minus 2 times D, plus dot, 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 plus A1. And now, if you do the same trick we did before, take the two equations and add them up. On the left-hand side is 2s. On the right-hand side, you are adding something where every column is the same number. Every column is equal to 2 times A1 plus n minus 1 times D. That is what every single column is equal to. And the reason it works is because this one has, you're adding one extra D, and here you're doing one less D. So just like it was in 1 to 1,000, when one of them is a little bit higher, the other one is a little bit lower, and it perfectly balances. So the sum is always the same thing. So we're adding up this term a bunch of times, 2 times A1 plus n minus 1 times D, and we're doing it n times. This is a sequence with n terms. So this is n times 2 A1 plus n minus 1 D. Okay, and therefore 2s is this, and therefore s is equal to n times 2a1 plus n minus 1 times d divided by 2. And I'm going to just rearrange this a bit. A1 plus n minus 1 divided by 2 times d. I'm going to write it like that. So the sum of a geometric sequence is this. This is in the notes. This is result 37. Result 37 in the notes. Result 37. So if you want to go to page 338 and check it out, in the notes they don't explain why. So that's why I'm explaining to you why. This is the formula. Here's the way you can remember the formula. N is the number of terms. The number of terms. And what is this whole thing in the bracket over here? This is the average term. And that's because, A1 plus n minus 1 divided by 2 times d, you go up by d every time. So if you add n minus 1 divided by 2 copies of d, that is exactly the midpoint, the middle term, the average term. Another way you could write it is it's the average of the first and the last term. Let me write that down. So s is equal to n times the first term plus the last term divided by 2. This is always a formula that works for arithmetic sequences. N times a1 plus n minus 1 times d divided by 2. That is exactly what we had before. And that makes, perfectly good sense. What is the sum of the formula? Well, you take the average term, which is the middle term for an arithmetic sequence, and it's the average of the first and the last term. You multiply by the number of terms. That's the sum. Okay. Should I do a quick example? Let's do a quick example. Oh, yeah, okay. So this is the example from my childhood, which is I had a test in grade 4 about adding numbers, and the test says, please do 1 plus 2 plus 3 plus 4. This was on the test. And of course, you can do this the regular way, but I had just learned this really cool trick involving, the whole thing with Gauss and everything, and I was really excited to use it. So I did the whole trick, and the teacher gave me full marks, but then wrote question mark, question mark, question mark on my page. What is the sum 1 plus 2 plus 3 plus 4? The answer is, it's the number of terms 4, and then the average of the first and last term. 1 plus 4 divided by 2. So 4 times 5 divided by 2, 20 divided by 2, also known as 10. That is the sum. Maybe I should do a harder one just for fun. Let's do the sum 101 plus 107 plus 106 So I'm going up by 6s here, right? It has to be an arithmetic sequence. 113. 113 plus 6. 119. 125. Okay. What is that sum? Okay, and of course you can do that when there's only 5 terms. You can just put them in your calculator and find out. But how would you do it? S is the number of terms, 5, times the average term. What's the average term? 125 plus 101 divided by 2. And in this case, the average term, 125 plus 101 divided by 2, is going to be the middle term, 113. 5 times 113. The average of 125 and 101 is 113. So that's the answer. What is that in numbers? 500, 550, 65. There you go. We did another one. Okay, so that's how you do the sum of an arithmetic sequence.